next is physical properties of haloalkanes and haloarenes. Physical properties of haloalkanes. Physical properties of haloalkanes and haloarenes. See, first is boiling point. Boiling point. So boiling point of haloalkanes and haloarenes is directly proportional to the molar mass. Normally the boiling point of haloalkanes and haloarenes are high because in haloalkanes and haloarenes they form a hydrogen bonding. Like if we are having a HCl, okay, RCl, CH3Cl, okay, so they form a polar bond minus. Similarly, again RCl, again plus minus, so they will form a bond. This is called the hydrogen bond, and because of this bonding they possess a high boiling point. Okay, so normally they are having a high boiling point, having they are having high boiling point and melting point. So haloalkanes and haloarenes normally possess the high boiling and melting point. Firstly, due to the hydrogen bond, physical properties of haloalkanes and haloarenes. So normally they are having high boiling point and melting point because they are having a hydrogen bonding. When the hydrogen is bonded with most electronegative elements, so it will form a hydrogen bonding. Second, their boiling point is directly proportional to the molar mass. Molar mass means the size of atom or the mass of the atom. If the mass of the atom is more, then there will be the collision. More collision will be there, and because of more collision, the spacing will be between the molecules will be less, and the collision will be more, and because of that, the boiling point will be increased. They, because of the bigger size, they will be closely packed with each other, and in the case of closely packed, they will possess a high density, and because of high density they will possess a high boiling point. Okay, so boiling point is directly proportional to the molar mass. Like if you have a question Ri, RCl, RBr, RCl and Rf, which will have the highest boiling point, then you have to select the Ri because it will have a maximum molar mass and maximum size, then RBr, then this and this. Okay, next is boiling point is inversely proportional to the branching. If there are more number of branching, the effective surface area will be decreased, and because of that, the boiling point like if you are having a compound CH3Cl, okay, like this, one compound is like C, one compound is like C, C So the effective surface area of this compound and effective surface area of this compound. So this compound have a larger surface area. Larger surface area compared to this lesser surface area. So boiling point is directly proportional to the surface area. If the surface area is large, the boiling point will be also large. If the surface area is lesser, then the boiling point. So the thing is, if the surface area is lesser, it means the branching is more. If the branching is more, the boiling point will be less. Okay. So this is about the boiling point. Next, melting point. Let's discuss about the melting point. So melting point of the compound is follows the settled packing of the molecules. Like if you are having a compound with symmetrical structure like this ClCH3 and this CH3Cl and this CH3Cl. So here as we can see that this has a symmetrical structure. So it will form a settled close packing between the molecules. So it will causes a maximum melting points. So the molecules with symmetrical structure will causes a high melting point. So its melting point will be the higher. Then usually its melting point is around 323. And this one is 249. And this is 256. So symmetrical structure causes higher melting point. Symmetrical structure causes high melting point. So melting point favors the settled packing of molecules. Melting point favors the settled packing of molecules in space. So this is about the melting point or the physical property.